3.4.4 Ultrasound. Ultrasound. Humans can hear sounds between about 20 Hz and 20,000 Hz in frequency, although this range decreases with age. Humans can hear sounds between 20 and 20,000 Hz. Ultrasound is the name given to sound waves with a frequency greater than 20,000 Hz. Uses of ultrasound. Extended. When ultrasound reaches a boundary between two media, some of the waves are partially reflected. The remainder of the waves continue through the material and are transmitted. Ultrasound transducers are able to emit ultrasound, receive ultrasound. The time taken for the reflections to reach a detector can be used to determine how far away a boundary is. This is because ultrasound travels at different speeds through different media. This is by using the speed, distance, time equation, where v equals speed in meters per second, meter per second, s equals distance in meters, m, t equals time in seconds, s. This allows ultrasound waves to be used for both medical and industrial imaging. Ultrasound in medicine. In medicine, ultrasound can be used to construct images of a fetus in the womb, to generate 2D images of organs and other internal structures, as long as they are not surrounded by bone. As a medical treatment such as removing kidney stones, an ultrasound detector is made up of a transducer that produces and detects a beam of ultrasound waves into the body. The ultrasound waves are reflected back to the transducer by boundaries between tissues in the path of the beam. For example, the boundary between fluid and soft tissue or tissue and bone. When these echoes hit the transducer, they generate electrical signals that are sent to the ultrasound scanner. Using the speed of sound and the time of each echo's return, the detector calculates the distance from the transducer to the tissue boundary. By taking a series of ultrasound measurements, sweeping across an area, the time measurements may be used to build up an image. Unlike many other medical imaging techniques, ultrasound is non-invasive and is believed to be harmless. Ultrasound can be used to construct an image of a fetus in the womb. Ultrasound in industry. In industry, ultrasound can be used to check for cracks inside metal objects, generate images beneath surfaces. A crack in a metal block will cause some waves to reflect earlier than the rest, so will show up as pulses on an oscilloscope trace. Each pulse represents each time the wave crosses a boundary. The speed of the waves is constant, so measuring the time between emission and detection can allow the distance from the source to be calculated. Ultrasound is partially reflected at boundaries, so in a bolt with no internal cracks, there should only be two pulses at the start and end of the bolt. Worked example. In the diagram above, a very high-frequency sound wave is used to check for internal cracks in a large steel bolt. The oscilloscope trace shows that the bolt does have an internal crack. Each division on the oscilloscope represents a time of 0.000002 s. The speed of sound through steel is 6,000 meters per second. Calculate the distance, in cm, from the head of the bolt to the internal crack. Step 1. List the known quantities. Speed of ultrasound, v equals 6,000 meters per second. Time taken, t equals 5 times 0.000002 equals 0.00001 s. Step 2. Write down the equation relating speed, distance and time. Distance, d equals v times t. Step 3. Calculate the distance. D equals 6,000 times 0.00001 equals 0.06 meters. Step 4. Convert the distance to cm. D equals 6 centimeters.